Hello everyone, this video is for my pre-calculus students. We're going to be going over lesson 37 today. We're going to be skipping a few lessons, 34, 35, and 36. A lot of 35 will be covered actually in this lesson that we do. I do want first to spend a couple minutes on page 186, pick up 35C, something you need to be aware of that he does. It's not really a new lesson, but just something that Saxon does, and it's done throughout calculus. We know that our function for a derivative is the function of x plus change in x minus f of x over change in x. This is what we've dealt with so far. In this, just a new notation, they are changing delta x, change in x, into just the letter h. So when you see this new notation, f of x plus h minus f of x all over h, you just know that it's the definition of a derivative. And I just need to point that out. And at the bottom of page 186, they do, or the lower half, they do an example using that new formula. They do not use the shortcut that we learned. They actually, it says find g prime if g of x equals square root of x. In other words, find the derivative of the square root of x. We learned the other day that's relatively simple. The square root of x we write as x to the 1/2 power. What is the derivative? Well, the 1/2 jumps to the front. We subtract 1 from 1/2, and we get -1/2. There is your g prime. If this is g of x, g prime of x is this right here. Okay, enough of that. On to lesson 37. In lesson 37, they're going to teach us the derivative of 4 things. The derivative of e to the x, the derivative of a natural logarithm of x, and derivative of sine and cosine. Don't know if I'm going to be able to get all 4 of them in today. We're going to take them at face value, and I'm just going to write them up. The derivative of e to the x is simply e to the x. Very nice. The natural logarithm of x is equal to 1 over x. Again, I'm not going to go through, if we ever come into class period again together, into the classroom, I'll go through and show you why this is true. Right now, we're just taking it face value. The derivative, by the way, I should show the derivative. The derivative of sine x is cosine x. That's a fun one to illustrate. But again, I don't want to do it now. And the derivative of cosine x is negative sine x. We'll go on from there later, okay? And find even more of these sines and cosines and tangents and what their derivatives are. It actually has lots of practical application in anything dealing with electronics and resistance and stuff like that. I'm going to go to lesson 37. I'm on page 193. And in the top half, they tell you this, the derivative of e to the x and the derivative of the natural logarithm of x. By the way, they do have absolute values around that. But we could also think of this as x to the -1 power. Okay? I'm at the bottom of page 193, 37.1. It says find the derivative if y equals, actually it says find dy over dx, dy dx. If y equals, and 4 ln x minus 6 e to the x plus 2 x squared. Now, in this problem, we're actually covering part of lesson 35 also, which was the derivatives of sum and differences. When we find the derivative, which is dy over dx, which we could have just written as y prime, it's always this constant right here, 4 times the derivative of whatever the function of x is. In this case, it's the natural logarithm of x. We just learned 3 minutes ago that the derivative of ln x is 1 over x. Now, don't worry about the fact that in the book they show the absolute value of x here, and this does not. That will come into play later, just again when we have more class time together face to face. Minus 6. Negative 6 is the constant, the coefficient, and the derivative of e to the x, we just learned, is e to the x. Plus, right here, the constant 2 times the derivative of x squared. I keep saying the constant, I mean to say the coefficient. The derivative of 2x squared is 2x, and 2 minus 1 is 1. Now, lesson 35, all it simply said was anytime you have a whole bunch of separate functions of x added or subtracted from each other, when you take the derivative, it's just the derivative of this one, and the derivative of that one, and the derivative of that one, added or subtracted together. It's really pretty simple. So we get our derivative is 4 over x minus 6e to the x plus 4x. Each of the terms, we took the derivative separately, okay, and then combined them together. All right, I'm going to 37.2. It says find this and tell how this derivative is different from the derivative in the other one. Well, in this one, the only difference is they do this absolute value of x. If you look at the solution, you'll see that they get the exact same answer. And at the top of page 194, it says the difference is that both the function and the derivative in this problem are defined for both positive and negative values of x, while the function of the derivative of the variable. Basically, it has to do with domain and range. What values of x can you put in one? What values of x can you put in the other? And what do you get out? All right. In this one, you were only, the original one, first example, you're only allowed to put in positive or negative values of x. In this one, when they put the absolute value sign, you can put in positive, and your domain changes. You can put in both values of positive and negative x, except x can't be 0. Okay? How much time are we on? We're at 8 minutes. Let's go ahead and do 37.3 at the top of page 195. It says find the derivative of 3 sine x minus cosine x plus 2 to the x. 2e to the x, I should say. Y equals 3 sine x minus cosine x plus 2e to the x. I'm going to put a negative 1 right there. So this is 3. The derivative is 3, and the derivative of sine. What is the derivative of sine? It is cosine. Minus 1 times the cosine of x. What is the cosine of x? Well, the cosine of x is negative sine x. Plus 2. And what is the derivative of e to the x? E to the x. So we get 3 cosine x. Negative 1 times negative sine gives me plus sine x plus 2e to the x. It's actually relatively simple. One more. We're at 9 minutes. 9.5 minutes. So the next one. Negative 3 cosine x plus 3 ln x minus 2 cosine x. I think I wrote that wrong. Minus 2 sine x. I was looking at the answer. Okay. Well, my answer will be negative 3 times the derivative of cosine plus 3 times the derivative of ln x minus 2 times the derivative of sine x. What is the derivative of cosine? Negative sine. And I'm going to leave off the letter x. What is the derivative of ln x? It's 1 over x. What is the derivative of sine x? It is cosine x. So, we get negative 3 times negative 1, positive 3 sine x, plus 3 over x, minus 2 cosine x. No real mystery there. It's actually pretty straightforward. Practical applications will come later. Thanks for watching, guys. Have a great day. Hope to hear from you soon.